All right, welcome back from wonderful weekend to this lovely fall weather, almost winter weather actually. Hey, it's not, look, you complain about the heat and now you're going to complain about the cold?
I never
Really? Really?
It's kind of like it skipped fall though.
It just went straight. It went straight from summer to winter.
I'm okay with that. Actually, I think it's going to warm up pretty quickly this coming week if I remember the
I
weather.
think tomorrow's supposed to be like 74.
Yeah. Good old weather.
Is done.
All right. So today we're going to talk about the STL. Y'all use this a little bit. I'm going to make sure we at least have one solid presentation on the STL. And then you'll have a lab, which is just basically fixing someone's STL code that someone wrote. But today, STL, talk about at least the main high-level view of what's going on. So the STL is the standard template library for C++. Remember, Java had this very large built-in library. C++ doesn't have anything built in per se, but pretty much every C++ compiler comes with the standard template library that you can include in your programs. And it is actually required it's in here, so you can call it part of the language if you wanted to. But yeah, you have containers, algorithms, and iterators. So a container is just a way to store data. You know, lists, binary trees we've looked at as well, or an array. They call them vectors here. Algorithms, the STL actually does include some algorithms for searching and sorting, as well as a slew of other algorithms. But we're just going to stick with search and sort for today, since we've looked into that, and now we can see how the STL does it. And then iterators. All right, do we remember iterators from Java? Just yeah, you got the right symbol. It's what was it exactly? Let's see if we can narrow that down.
Something that went through like the whole array.
It could go through an array, but did it have to be an array?
No.
It could be, so it's really just an abstraction of how to iterate or traverse through some container.
Yeah.
And since it's templated, that means that we can store any type of data with any of these three things. All right. So this is the way they want you to think about it. Sure. Your containers holding either objects or primitives. In C++, it does not have to be an object. It could be primitives. And then maybe you want to call some algorithm, some sorting, which would iterate through it or do something with all these containers and objects and put them possibly in another container or have an output as well. Different ways to look at it. Okay, let's go ahead and at least touch a base on the containers. I think we went through all these in Java, so these are going to be the C++ version. So a vector is a one-dimensional array. Now it's templated. So whenever you think of templates, always remember that you can always template on yourself. So a vector is a one-dimensional array. So a vector of ints would be a right. And then if you have a vector, then it's a there we go. All right, good. We're all tracking. All right, the list is a doubly linked list. They just called it a list. And that'll behave very similarly to the way we did it. DQ is a double-ended queue, so you can add and push to both ends of the queue, and then you have the regular queue, basically only in the front. Stack, just like we did, and then a set. All right, what's the difference between a set and a list? Or actually, are we good all the way up to stack? Let me stop there. All right.
Vector is an array that can be changed in size. Is that what it is?
Right. Think of array list in Java. So it'll hopefully internally resize itself. Now, it does overload the subscript, the solid block brackets, but so it's not going to automatically resize itself if you're outside of range. You have to do that manually. But you can push to the end or insert in the middle if you want to, and then it will go ahead and resize itself if necessary.
Gotcha.
Of course, all the algorithms are the same.
the algorithms.
As far as like runtime, like the resize is still like.
Yeah, it's still, it's not like they made arrays faster somehow and magically. Yeah, it's still the same thing. These are just library tools, so you don't have to use our classes arrays. You can use basically STLs. And why do you always want to use the libraries version?
It's optimized code.
It's optimized, that's
It's
true.
been tested.
And it's been well tested. Those are the two reasons over here. So yes, definitely out in the real world, use vectors. And moving forward, you can use vectors because we're done with arrays. So if you want to have a vector inside your labs moving forward, or a list, or a DQ, or Q, or a stack, that's perfectly fine. You don't have to use the old code if you don't want to. In fact, I do recommend using the STLs because it's going to give you experience in it, and you know it works. You don't have to worry about an error inside of your code. All right, on to a set. So what is a set? You've probably done this in math, haven't you? Did you take discrete math? Or anyone?
I did.
You took discrete. Have y'all done, those that haven't, have y'all done set? There's a set of numbers, set of,
It sounds familiar.
sounds familiar. Don't remember, okay. All right, so a set you can, let's see, how to say this. The idea of looking at a set as opposed to a list, in a set you're just holding a bunch of numbers, not necessarily in any order, but the optimization in set is, does this set, contain something, which is different than a list. Because a list, you're trying to keep them in a certain order usually, or you're trying to be able to add and remove quickly. In a set, you're not going to be able to necessarily iterate quickly, but you can very quickly ask, is this number in there? Also with the set, they usually with the set, you can only have one number, so every element has to be unique. Because again, the optimization is, does this exist in the set? All right, map, associated array. Y'all done, remember hash maps or hash tables? Right, so that's what maps are in here. Now we haven't done maps and sets, so don't use those in the coming labs. But we'll get to those soon. All right, any questions on these containers? Before maybe doing some example, would you like some example code? How about that? Sure. Yes. All right. All right, which one do you want? Cool. There we go.
Which one is harder?
Which one is hard? They're all easy. That was a tough question. All right, we'll do vector because that's a classic one. I'm going to go ahead and show you how you look up the keyring. So I just do C++ vector if you want to look up how to use it. Hey, look, a reference. First, you need to include vector, so let's go ahead and do that. Wow.
Somewhere, someone on Stack Overflow is freaking out.
What?
Because you're using vectors. Because that's their solution for like everything.
Is to just use vectors?
Yeah, you use a vector.
Use a
Why
vector.
wouldn't you? I don't know why you wouldn't.
Yeah,
Doesn't
but when
make
you just
sense.
use a vector.
Why would you just use okay.
Yeah.
Why would you just use a vector? Alright, so we need to include vector. And we'll go ahead and put up our boilerplate code. Let's see. Ooh, with 2 T's. Alright, so we include vector. Let's see what we have. It actually tells you about all of it. Internally, vectors are dynamically allocated array to store elements. It may need to be reallocated to grow, so it may do it sometimes. There's relatively expensive task in terms of processing time, and thus vectors do not reallocate each time an element is added to the container. Instead, they may allocate some extra storage to accommodate for possible growth. So remember, it's good to read about this, what's going on. And so the actual capacity may be greatly greater than the storage strictly needed to contain the element, aka its size. So the reason why that's important is that's why they have capacity as a function and size as a function, and those two things may not be the same. So you may have some extra capacity with your vector. All right, so we have different elements here, and it's good to look at the constructors first. Whoops, member functions constructor. All right, 98, C++ 11, 14. The autograder uses C++ 14, and C++, in all to the best of my knowledge, they're all backwards compatible. So if you write 98 code, it'll also work under 14 code. So let's just stick with 98 because I don't want to make it any more complicated than it is. And it looks like, oh, so this can be confusing, but you have const allocator type, allocator type. I feel like I'm saying alligator type. If you look at this carefully, they're automatically assigning what the standard allocator type is. And that means you can actually overload the function that's called whenever the vector allocates memory. This is useful if you're doing system programming, or if you have a program where you need to do allocation in a very specific way, then you can tell it how to get the memory. If not, just use the default one, and for this class, just use the default one. But keep in mind that you can actually overload how the vector is sizing itself, or what mechanism it uses to get to allocate memory. There we go. All right, so there's a default constructor. That's great. So let's go ahead and what do you want to be a vector of? Ints. All right, good. Let's make it easy. I'll call it ints. There we go. So it's on the stack. That's great. Let's go ahead and make sure this compiles, just to make sure we did everything correctly. Yeah, it compiled. And then we'll just run it just to make sure we don't have any issues. Perfect. All right. Now, just to see, let's see what the starting capacity is. Ints.capacity. Oops, I meant to do that. See how it doesn't exist? Probably because I should include IOStream. Starting capacity 0. All right. So if you want to change the capacity, you do ints dot, I think it's just capacity. We'll pass it to 100. You don't have to necessarily do this at first. But let's go ahead and jump back. Capacity, return, oh, that returns the size of the allocated. So that's not going to be what we want. Reserve is what we're actually looking for. And the new capacity afterwards. And new capacity 100. So you can't actually reserve the capacity if you want to. I'm going to comment that out for now. You can do ints.pushback, which is probably the function you're going to see a lot if you look on Stack Overflow. And this is going to push it to the back of the array. So at the end of it, what number would you like to add?
14.
14. And let's see what the new capacity is after we add one element. Oh, just one. Wow. All right. Let's add another one.
7.
2. Seems to be slowly reallocating itself. Not necessarily the most efficient algorithm. One thing I will say is in the back end, there are mechanisms to do reallocation quickly. And that's probably what it's using right now. It's calling realloc instead of new, which is more efficient and can resize itself nicely. All right, so pushback.
Are there any, did you sort itself, or is there a sort option?
There is a sort. It's not part of arrays. It's part of algorithms. So we'll get to that in a little while, though. In Java, sort was a member of the actual class. Well, not necessarily, but in C++ it is definitely separate. Let's go ahead and just add a bunch of numbers. And no, let's not do it that way. Let's make them. What do you want the next one to be?
12.
12?
22.
22.
18.
18.
103.
103.
96.
96.
4.
Thank you.
Beautiful.
That was awesome. Alright, we're going to put out the capacity, and we'll also put out the size. Alright, let's go ahead and print that out. Alright, capacity 8, size 8. Great. So, now remember, it's a vector, so it's going to behave. They try to overload all the operators so that the vector behaves exactly like an array. So that means you can use your solid subscripts. So you could do for int I equals 0, I is less than int dot size. Now what's nice is, since it's a class, you can now just call the size operator or function on it and get the size. I plus plus. We'll do int the subscript just like it's an array, and we'll put a little space right there. And then afterwards, we'll do an inline. All right. And there we go. Now let me go ahead and comment a couple things. The not recommended way of iterating. They actually recommend you don't do it this way, even though I think it's okay. They don't recommend it. But one thing I want to say, let's see, what happens if you try and do this? Ooh, this is a trick question. What happens, actually, yeah, trick question. What happens if we try and do this?
Does it output the memory location?
What? Isn't that out of bounds?
It is out of bounds, yes.
Okay.
What would happen in Java?
It would give you an error.
An error. What happens to C++?
It would say it's okay.
It would just give you something.
It may give you something, it may segfault. It's the actual...
It depends.
It depends, thank you. It depends. The official specification says the behavior is undefined. AKA, it can do whatever you want. We don't care. That time, it decided to go ahead and print out a number. But if you ran this enough, maybe at some point it would actually print out the same number each time. That's interesting. At some point, it may segfault, or it may not, depending on your operating system and how the program is working. Okay, now, so the not recommended way of iterating, and now for the recommended way of iterating, which, in all honesty, I never do because it's just annoying. Let's see. So you have to use these begin functions. Let's do it. So iterator begin, okay. So you go for, let's see, was it capital I? Iterator on int I equals int dot begin. I does not equal int dot end I plus plus. And I'm going to see if I type that correctly, because I probably did not. Nope. Not declared in the scope, probably because I need to include it. And it's with the lowercase I. This is not Java. Right, so it's actually standard vector. There we go. And the int is part of vector, not part of iterator. So we have to get the iterator of vector, call it I. I was not declared in the scope. And I only used one semicolon. Let's try that again. There we go. Whew, that was fun. All right. You can see why I usually don't do it this way. Part of the standard namespace, part of vector. Every container has an iterator. So you get to the iterator by using this. That declares the type. It is an iterator of vectors. We're going to call it I, just like we called it I up here. And we're going to begin at the start of the object. And to get that first iterator, we call inst.begin. All right. So that gets the iterator pointing to the beginning of the container, which is of vectors. Then while I does not equal the end iterator, increment I. So it goes to the next one. C out, and then you dereference I believe is the way it works. Yep, there we go.
Does it really matter which one you do? Like,
For this course, no. I'm not going to grade you one way or another. Why would the second one be recommended?
It would never go out of bounds.
True. There's a bigger reason, though.
well, I assume that if you do it that way, you're using pretty much the code they already have written more, so it's more efficient.
Yes, that's definitely the case. Think of a list. If you're using an iterator to go through the list, you just go one by one. You're using iterators, it's going to go one by one to the next one. Up here, you're using the subscripts. You know, it's got to go through the whole list because it's a linked list, not an array, to get to every element. So in general, the iterators are more efficient. There's one last reason, although it's not very apparent because of the way this code is. You can use generic iterators. So instead of using an iterator on top of vector, you can use a generic iterator. And that means that if you're using a function and you need to later switch out a vector with a list, you just switch out the vector of the list. You don't have to rewrite all your for loops anymore. If you do this correctly. But notice that with the iterator, plus increments it, and then minus would decrement it. So what would we need to do if we want to print this in reverse using iterators?
We have to flop the end in the beginning and then use minus.
Yeah, let's try that. Let's see if that works. And then we have to use minus. Almost.
So then we have to do in minus 1.
Yeah. You have to start at n minus 1. That's the first thing, because the end is actually after the last element. All right, and we're almost there. Because once it does equal begin, you're actually done.
Okay. So then you need plus 1 here too? Or
There's different ways to do it. I'm going to do in begin minus 1. And I think that's the easiest. Iterate one back, then you're okay. Not quite intuitive exactly what that means, but that is a way to do it. And it's also technically container agnostic. So, all right. And let's look at a couple other functions of vector before we complete. I think there should be insert and remove. Push back, pop back, insert. So we can insert an element at a position and a value. So let's go ahead and inst.insert into position, I don't know, 3, what value?
47.
47. And then we'll go ahead and do it the recommended way. Expects 3 arguments to provided. What did I miss? I only see 2. Oh, iterator position. ints.begin plus 3. So that's position to add the element. Let me get this \n up here so it's a little easier to read. All right, so the 47 happened at the 3rd position between the 12 and the 22. Any questions so far? All right. And remove should just give me the position of remove. Oh, it's erase. Iterator position, perfect. Notice you can also erase from one position to another. So you could erase a whole list of numbers at once if you wanted to. All right. Which one should we erase? The 5th one. Thank you, Jonah.
Okay, the 5th one.
Let's erase 2 others.
The 7th.
7th one at that point, which is really the 6th or 8th. Yeah.
And the 2nd.
And the 2nd. Okay. Going. All right. So definitely remove those numbers. Lastly, before we complete, let's go ahead and print out the capacity.
Have like a print for vectors?
I'm sorry?
Don't they have like a already like kind of presetted print function for vectors or
I would not expect them to. Let me go look. Sign pushback and swap, clear, imbalance. No, I don't see it. I don't think they would have a print function because you may not be printing to the console. You may be printing somewhere else. In this class, we're only using C++ to do the console because that's easiest. I don't want to make y'all have to write GUIs for every single lab. See, I'm not completely evil, Jim.
Yeah. Just a tiny bit.
Just a tiny bit, just a little bit in there.
Just a little bit in there.
Yeah. So you may be printing to somewhere else. So I didn't add it to the library. Okay. So I'm going to print the capacity and the size after this. I'm going to take, just out of curiosity, what do you think the capacity and the size would be after this final removal? What should the size be? That should be easy.
6.
6. Okay, great. Now what would the capacity be?
The capacity stay the same? Don't know.
You don't know for sure, but probably.
Okay.
Oh, that went up to 16. At some point, they decided to double it. But they well, the important part here is they never reduced the capacity after it grew to a certain point. Okay. Any other questions on vectors? I haven't talked about the algorithms on vectors like sort and search. That's something different. But any other questions about using vectors? Make sense so far? Okay, great. We'll go and pause the